Alright, so in this lesson, let's begin where we left off, using the side-side angle rule. Determine how many triangles each case would have, and then turn the video back on when you're ready to continue. So in these triangles, we have different letters this time. So as one of the comments I made was that we're looking at, is the side opposite the angle longer than the other side? So this case here we're looking for is B greater than or equal to A? And if the answer is yes, then we have one triangle. If the answer is no, then we will go on to step 2, which is our sign rule, which in this case here is going to be comparing B times A sine of angle B. So again, these are opposite each other. So the first one, 15 is not greater than 23. That's false. So that means we have to use the sine rule. So we're looking at 15 compared to 23 sine of 40 degrees. So if it's less than, we have no triangles. If it's equal, we have a right triangle. And if it's greater, we are two triangles. So 23 sine of 40 degrees is 14.784. So it is greater, so that means we have two triangles. In the second example, we have 15 is greater than 12. That's a true statement, so there is exactly one triangle. So whatever number is opposite the angle, that's the number where the first number in our inequality being compared to the other number. If it's greater, one triangle. If it's not greater, then we have to use our sign rule. We're moving on. So in our discussion today, there are two cases that will continue to show up. So if we have this, the side that is opposite the angle, if I would list this as 15, then followed by the other side, followed by the angle. I'll put it in that order. When this side here is longer than at the other side, that's the one triangle case. So you'll see a large capital S, small s. Capital means it's the longer side. So capital S, lowercase s, and followed by angle tells me that there's one case. In the second problem, we have 15 followed by the 23 followed by the 40-degree angle. In this one here, the first side opposite the angle is actually shorter. So you see the short S, capital S follows it, means the longer side. So you might see as we talk through this, the idea of the short side, long side angle, which is the first one, long side, short side angle being the second example. So for the remainder of this activity, we're going to focus in on the two triangle case. So that would be short side, long side angle is either going to give me a 0, 1, or 2, depending on how the sign rule works. And what we're going to focus in on is, okay, there are two triangles, and what do they look like? Where if we have, again, the long side, short side angle, it's always one triangle. So that's the case with a perhaps going further. So each of the triangles shown has two different triangles. Use your calculator to find the measure of angle A, round your answer to the nearest 10. Your calculator will only provide you with one of the angle measures. So in other words, every time we've done a side-side angle problem in class, your calculator is giving you one answer. And if you continue to do the problem over and over and over again, the calculator is only going to give you one answer. And so the reference I want to make is to the problem we did last week, where we had a situation where we had like a negative decimal number, and we talked about converting that back into an actual angle measure.
using the inverse cosine, that it gave us an angle that was obtuse. And what I did in class was I removed the negative sign to show you that what would happen if I did inverse cosine in the positive decimal number. And so when we compared the two answers, the two angles actually add up to 180 degrees. So they were supplements to each other, called supplementary angles. So as we work through this activity here, keep in mind that hopefully there's some patterns here that will allow us to understand if there are two triangles. If you find the first angle, then what's the second angle? What's the second triangle going to look like? All right. So as you find angle A first, and then it asks you to use your compass to draw a circle CA, where C is the center and goes through point A. This will provide the other location for point A. So keep in mind, when we did the GeoGebra sketch using your Canvas page, when we slid that side around so it intersected the angle, it either didn't touch it at all, touched it once, or touched it twice. So in this, what you're doing here is by drawing that circle, you are showing the two cases where the 2 points or locations would be for point A. So go ahead and find the measure angle A. Go ahead and complete the construction and answer problem 4 when you're done with construction, and turn the video back on. All right, so since we have an opposite pair, angle side pair, we use law of sines. So we cross multiply. What I get is 8.6 sine of 35.5 degrees. So we divide by 5.4, and that's going to be what sine of A is going to equal. So we're going to put in 8.6 sine 35.5 degrees. And then we're going to divide that by 5.4. The answer by 5.4. So this is the decimal number I get. 0.924823.226. And that's my sine of A. To find the measurement of angle A, we need to do inverse sine to both sides to give them sine. So angle A is going to be whatever the inverse sine is of the decimal number we come up with. So the inverse sine of that decimal number has to run the tenths, so we're getting 67.6 degrees. So if I would again open up the compass here, open it up to here, and then draw a circle, so an intersect over here, we call that A prime. And the question asked in here, which is problem 4 here, what kind of triangle is AC A prime? So hopefully you said isosceles. Because this length over here is also 5.4. So you have an isosceles triangle. And if you would please put in all the numbers that angle measurements that you know based on geometry class, and then turn the video back on when you're ready to continue. All right, so hopefully you mark this angle here as 7.6, because in an isosceles triangle, if there are 2 equal sides, there also are 2 equal angles. Talked about this earlier. These are called the base angles. This side here is called the base side, which is normally different. And then the angle at the top it's called the vertex angle. It's going to be whatever left of the 180 degrees. So 180 take away 2 7.6s. These are 44.8 degrees. Now, on the other side of angle A, these 2 angles here actually make a straight line, so they're always straight angle. So 180 degrees take away the 67.6 degrees.
leaves you with 112.4 degrees. And then 180 degrees, take away the 45.5 and the 112.4. Makes it angle up here 32.1 degrees. So continue with problem 6. Problem 5 actually find the angle. Continue with problem 6. Ask you to redraw the triangles. And so this is a 35.5 degree angle. We know that. This side here is 8.6 and this is 5.4. And then the bigger triangle also had the 35.5 and the 5.4 degree angle there. And this 8.6. I'm going to stop right there for a moment. So again, keep in mind that your trig work, your law of sines, will only give us one answer. That was that 67.6 degree angle. But by doing the construction here, we actually come up with the second triangle that has the same information for side-side angle, and they're both being pictured here on the board. So we have 8.6, sorry, 5.4, 8.6, followed by the 35.5 degree angle. So going this direction, we're showing side-side angle. It's actually the short side, long side angle. And we have both cases here. So so when you do this problem, it's going to give you the 67.6 degree angle here. What it's not going to give you is the 112.4 degree angle here. And so to find that second triangle, by drawing in that circle, we can actually figure out the angle measurements and identify the angle measurements for both triangles. As we're doing this, look at both triangles and make some decision. If I find this angle here, then how do I find this angle here? Because again, it's going to be the second side-side angle triangle for this pattern. And so finally, in terms of the angles, this up here is 32.1, and then the angle here is going to be these two put together, which is 76.9. We're asked to find the missing sides. So in both cases, we have one triangle or one side left. So I'll leave that for you to work on. And we're going to go down to the bottom of this handout. So this video is getting pretty close to being finished. I want to stop it here because I have about a minute left. And then click on the next video. We'll look at these two problems here. Would you go ahead and get started on repeating the steps and trying to find, that angle A, and then using your compass, construct that circle CA to come up that triangle, and also that second case for triangle BCA, and it means BCA prime, the second triangle. Turn the video back on when you and your partner are ready to continue.